Okay, this video will go through the simple rules of differentiation. You've probably covered a lot of this already, so I will go through it quickly, some parts, but certainly you can pause it anywhere along there if you need to. So it's just note the notation. If you start with that, there's the derivative. If you start with y, there's the derivative. And just another one, just note, if you've got y equals, x squared plus x, another way to do the derivative, which is quite clever, they can write dx squared plus x dx, right? So what they're trying to say is, listen, y is actually equal to that. Can you just find the derivative of it? Okay, so you've got your rules here. So just remember, any constant, the derivative is zero. With our n, we put it at the front, there it is, and we subtract 1. If there's a constant out the front, just leave the constant out the front. When you're diffing, it should have a subtraction here too. When you're diffing two separate x's, you diff each one separately and put a plus tag between them. If you've got the number at the front, like 5x, the derivative is just the constant 5, okay, or c, all right? So we'll look at some of these to start with. All right, so very quickly, f dash x for these. I usually just leave the constant at the front and just diff the power. So we've got 3x squared, right? 6, so the 2 goes out the front, 2x1. I remember our rule just before, that just becomes the number. Remember, this guy just becomes 0. You can leave it like that, all right? Let's do the next one. F dash x, I'm going to leave the 3 out the front, so it becomes 2x1. Now this one is a bit strange. What do we do with a different letter? We are diffing with respect to x. Any other letter becomes a constant. So even though it's like 3D, you can just pretend it's one big constant. What's the derivative of one big constant? 0. Don't forget we've got 20x at the back, so that derivative of 20x becomes 20. Okay, so just don't forget that one. All right, now remember when we have fractions on the bottom, okay, you can see we've got an x1, you've got to turn them into negative indices. So f dash x equals 7x. Take 4 to the x minus 1 plus 3x to the minus 3. Okay, I hope that's all right. If you're not too sure, for example, how do you break it up? That's really the same as negative 4 times 1 on x, which is the same as negative 4 times x to the minus 1. Okay, so the same rule can be applied to the second one. All right, let's diff it now. So I said that was the derivative. It's not, is it? It's just another way to write f of x. So let's find the derivative underneath. So f dash x equals 7. I'm going to leave that constant out the front. So negative 1 goes out the front. Subtract 1 becomes negative 2. Leave the constant 3 out the front. Put the negative 3 out the front. Subtract 1. Negative 3 subtract 1 is negative 4. And the last one over here looks a bit different, but let's just follow the rules, right? So the f dash x, keep the 3 out the front. So the rule is you put that out the front. Okay, it's out the front. You then subtract 1 to it. So if you've got n take 2, if you subtract 1, it becomes n take 3. There's a constant at the back, so it would be 0. All right, you can just leave that alone. That's kind of factorized. Happy to leave it like that. All right. Okay, let's have a look at another question. Very similar, just says find the slope function. So another word for that is just find f dash x. Remember, the slope function is also the slope function of a tangent, and that's what they're asking here. So hence, find the slope of the tangent when x is 2. So really what you're going to do is find f dash 2. So first things first, let's rewrite f of x, where we've got that negative indice on the bottom being pushed to the top to become negative. Now let's find the derivative. So x squared is just going to be 2x to the 1. Keep the negative 4 out the front. It'll be minus 1x to the minus 2. And now I think we should tidy this one up. So it's going to be 2x take becomes plus 4x to the minus 2. And I might bump it back down the bottom. You have to return it into a positive when you're substituting values in, okay? So you can't solve something when it's got a negative indice. So I'm just going to use note the notation. So I'm going to do f dash 2. So that's going to be 2 lots of 2 plus 4 over 2 squared, which becomes 4 over 4 over 4, which is 4 plus 1, which is 5. So that's the slope of the tangent to that function when x is 2. All right, the next lot of questions, you can see a few of these things here. All right, we saw them in first principles. So if you're not too sure, like for example, x root x, another way to write that is x times x to the half. And another way to write 1 is 2 over 2. So remember, you multiply with the same base, you add the powers. So 2 halves plus a half is 3 halves. Okay, and you can do the same for this guy. It's really 2 times x to the half, which becomes 5 halves. Okay, so let's use that rule to help us do a few of these questions here. So the first one, we don't need it. We just have to convert that root to a half plus 2, just like we did before. That becomes x minus 1. So the derivative, keep the constant out the front. So put the half out the front. And just do it over here. If I have to subtract 1 to a half, it's the same as 2 halves. So 1 take 2 is minus 1 half. So your new power is minus 1 half. And you've got plus, so that's all in the bracket, plus 2. I'm going to run out of space. Plus 2, and we'll do the same thing here where we put the minus 1 out the front and then subtract 1. That's okay for now. If you look at Hazy, which you're going to get the majority of questions from, they'll rewrite it like this. Okay, and then they'll actually turn the x's into positive indices. So just be aware that even though that's okay as an answer, when you're looking at textbook questions, they'll probably rewrite them as positive indices, right? So the negative half becomes a positive half on the bottom, okay, and the negative 2 becomes a positive 2 on the bottom too. All right, let's have a look at the second one. So it's very similar, this one. We'll rewrite it. So that's a half on the bottom, so it just becomes minus a half when you put it on the top. So derivative of the first one, that's nice, 2x to the 1, or just 2x. Keep the negative 4 out the front. Now we've got negative a half that has to come out the front. So we'll just do that over here. Negative half take 1, so it's going to be the same. So negative 1 take 2 is negative 3. Okay, so it's negative 3 halves. All right, and we'll leave it like that. But like I said, if you use a textbook, you'll find that they will be simplified in those cases. All right, we've got x root x. Now, if you remember before, x root x is the same as x to the 3 on 2. Okay, so when we're diffing this one, really just remember the constant out the front is just going to be derivative is 0. You've got a negative 1 out here, so why don't we leave that there? Put the 3 on 2 at the front. Maybe we'll do this. 3 on 2, subtract 1, right, is 2 halves. That's going to be 1 half. All right, and that's your answer there. We don't really need the 0 there. And this one here, do you remember we had to split them up sometimes? So if I've got a plus b over c, that's actually one thing on the bottom. Okay, we can write it as a on c plus b on c. This rule is kind of defunct in some ways. We could use the quotient rule, right? But we'll pretend we haven't got that yet. So I've really got 1 over x root x. Let's rewrite that as x to the 3 on 2, shall we? Plus x on x to the 3 on 2. So remember, x root x is x to the 3 on 2. Now I'm going to rewrite that as 2 on 2. So I can rewrite this as y equals x to the, put that to the top. Now we can diff it. Remember your rules about indices, you subtract. So 2 halves take 3 halves. I might just write that over here. 2 halves take 3 halves will give us minus a half. So we've got plus x to the minus a half. All right. Now we'll find dy by dx. So we'll just put the negative 3 on 2 at the front. So negative 3 on 2, take another 2 halves is minus 5 on 2. I'm not going to write that one down. Plus, and then it'll be minus a half x. Minus a half, take 2 more halves is going to be minus 3 halves. All right. A few fractions in there. I know they're a bit of a pain, but we do have to work with them. All right, so we've got a few other questions. This question says find dy by dx. Hence, find the x value. So we have to find x when the tangent to the graph is horizontal. So we want the tangent to be horizontal. So I hope you guys understand. Here's a graph. It's a key feature, right? There's where the tangent is horizontal. I hope you guys understand what the slope would be there, right? The slope would be 0. So what we have to do is we first have to find dy by dx, right? Which is the slope function. And then we're going to let dy by dx equal 0. And we'll solve for x that way. So let's find dy by dx. So dy by dx will be, let's put the 2 out the front straight away. So it becomes 6x to the 1. And then with the constant times x, it's just that. So we are going to let dy by dx equal 0. So this is the slope function. And so what we're going to say is let's let the slope equal 0. And by rearranging that, so just add 4 to both sides, divide both sides by 6, you'll get the x value where this tangent is horizontal. And that's a key feature. We'll talk about them a lot more down the track, but that key feature is a turning point, right, or a stationary point. So we know that when x is 2/3, this graph has a turning point or a stationary point. Okay, good. Just 2 more to go. So using the chain rule, I don't think I spoke about that on the previous page. I guess you just got to think about the chain rule is this whole thing here, we kind of pretend it's like x, right? So when we do the derivative, we still do the same thing. We put the power at the front and then subtract 1. You just got to realize that we haven't got x in here. So what happens is we times by the chain. So the chain is this guy in here. All right, so the derivative of that is going to be 2x take 2. And what's really important is this has to be in brackets, okay? If you don't put it in brackets, you might make a mistake. So remember when you do the chain rule, you sort of follow the same rule with putting the power at the front, subtract 1, but then you times by the chain over here. Just note this does not change at this step, okay? Some people will do the derivative of this here. You're not supposed to, okay? Now let's do the same here. You just need to be aware that we've got 1 take 2x to the half. Let's put it to the top, hey? I hope that wasn't too quick. So that's really the same as 1 take 2x to the minus a half, okay? Because at the moment it is to a half on the bottom. Let's put it onto the top. So f dash x, so the 4 just stays out the front. Let's put the half, minus a half out the front, right? Now if we subtract 1, so maybe I'll do that. Remember, if I've got minus a half, subtract another 2 halves, that's got to be minus 3 halves. All right. Now, I feel like I've finished. That's a lot of work, isn't it? But remember, I've only done the first step. I've put the power at the front, subtracted 1. Don't forget, I've got to multiply by the chain. So here I have to do the derivative of this guy. So the derivative of that is just negative 2. All right, that's a constant, that's 0. The derivative of the second one is minus 2. And we're done. Right, so the idea is you just got to practice it, but you might find later it is more difficult because you might have to, for example, in this, you might have to find a value, right? So you'd have to tidy that first up. So that would be negative 2, that's negative 4, really. So you can see that all changes to be positive 4. And then this might surprise you. This is actually what you would have on the bottom, right? Remember, if you put that on the bottom, it would be 3 on 2, but then we knew before, that would be 1 take 2x times by that. All right, that's something for another day, though. Okay, we'll just leave that alone. You just need to realize that we might have to sub into these a little later. All right, got some questions there. Off you go. All right, and remember the answers in the back might be a bit more simplified. Okay, good luck.